So another problem is that it can be very hard to do debugging when the test case is either very large and or nonsensical. And so what I mean here is that the random test case that triggers a failure in some software under test might be many megabytes long, and it may have no sort of usable human interpretation. And under those cases, debugging the software under test can be really hard. And there's a solution to this. And there's a pretty good solution to this problem that I'll talk about a little bit later. And so a final disadvantage of random testing is that every fuzzer, and a final disadvantage of random testing is that people's experience is that every time you write a new fuzzer, it finds different bugs. And what this basically means is little incidental design decisions in the random test case generator explore subtly different parts of the system under test's input domain, and that results in finding different bugs. And this shouldn't be a surprise given the extreme difficulty of the testing problem, but it's still a little bit demoralizing when you spend a lot of time writing a fuzzer, it finds a lot of bugs, and you think the system is getting pretty robust, and then somebody else writes a really simple fuzzer, and it finds a whole bunch of bugs that you couldn't find. And this is very common for that to actually happen. So that's a long list of drawbacks, and these drawbacks are real. But let's go back and look at the other side of the trade-offs. So on the advantage side, random testing has less tester bias, meaning that testing is less influenced by what I know about the system's implementation. And random testing also has weaker hypotheses about where bugs are. Maybe that's just another way to say the same thing. So besides this issue of bias and hypotheses, perhaps the real killer advantage of random testing is once you implement a random tester, and once you automate the testing process, the human cost of random testing is basically zero. And so this has certainly been the case with this C compiler fuzzing effort that I've mentioned several times, where we spent a long time developing this random tester. We worked really hard on it. But since we more or less finished it up a couple of years ago, it's been finding on average a bug or two a week in real compilers with almost no effort from us. So we have a machine sitting in a dark room somewhere that's doing random testing, but it's running by itself. It needs almost no oversight. All we have to do is look at the results and write up some bug reports. And this process of turning random tests into bug reports is something that we'll come back to a little bit later. So an extremely interesting and useful thing about random testers is that they often surprise us. I've had the personal experience of being surprised by random testers many times. And also, in the course of reporting about 450 compiler bugs, I found that compiler developers are often really quite surprised about the behavior of their tool. So random testing sort of consistently has this ability to tell us something that we didn't know, and that's extremely valuable. And another advantage is that every fuzzer finds different bugs. And so, of course, I included that under disadvantages as well, because it's sort of depressing at some level. But on the other hand, this is really cool. So what it means is if we have several fuzz tools, might as well just devote a couple of cores to each of them, and more than likely, there's not even going to be that much overlap in the bugs found by the different random testers. And finally, due perhaps to some combination of these other advantages, I at least find random testing to be really fun. It's fun to have stuff automated. It's fun to be surprised about the system. It's fun to have shortcomings in our logic pointed out by a process that doesn't have a human involved. It's really just interesting to have this happen. And it's really just interesting that this kind of stuff happens.